Some people think AI is just a clever chatbot. Others believe it's already capable of replacing white-collar jobs, that we no longer need developers, data scientists, or project managers. But that's not how it works. In this free mini course, I'll show you what AI is and what it isn't. I'm going to clarify the key concepts behind modern artificial intelligence and debunk some of the most common myths. By the end, you'll have a clear, realistic understanding of how machines actually learn, step by step, in plain English. This series also serves as a great warm-up for my full iOS machine learning course. Yes, I'm trying to sell you something. Where we take these ideas further and build real smart apps. So if you've ever wondered what's really behind the intelligence in artificial intelligence, you're in the right place. Alright, let's start with the foundation of modern AI. Machine learning. Machine learning isn't new. In fact, the term was first introduced in 1959 by Arthur Samuel, an early pioneer of artificial intelligence. He defined it as the field of study that gives computers the ability to learn without being explicitly programmed. In other words, a computer program is set to learn when it gets better at a task through experience, not because we keep rewriting the code. So what does that actually mean in practice? Imagine you're driving to a popular restaurant. You know that part of the city and estimate it will take less than 30 minutes. So you leave 40 minutes early just to be safe. But you end up stuck in traffic and miss your reservation. This kind of prediction problem can't be solved with traditional programming. You can't write rules for every possible traffic situation. Instead, apps like Apple Maps or Waze learn from millions of past trips, current traffic data, and real-time user reports. The more data they process, the better their predictions become. Still, they are never 100% accurate. They are making educated guesses based on patterns. If there's an accident or a road closure that hasn't been reported yet, it won't know about it and the prediction will be off. Traditional programming is deterministic. If X, then Y. Machine learning is probabilistic. Given X, Y is likely with 92% confidence. Think about your email spam filter. Nobody programmed it with millions of rules like, if the subject contains Nigerian prince, mark as spam. Instead, it learned from millions of examples of spam and legitimate emails. It identified patterns, certain words, sender behaviors, formatting styles that tend to appear in spam. Now it can catch spam emails that didn't even exist when it was trained. Machine learning can solve problems where rule-based traditional programming approaches would be impossible or impractical. How would you program rules for recognizing faces in photos, predicting which customers might cancel their subscription, or determining if a credit card transaction was fraudulent? You couldn't. But you can show a machine learning algorithm thousands of examples and let it find the patterns. When we say machines learn, we're really talking about optimization. The algorithm adjusts its internal parameters to minimize prediction errors on training data. The ultimate goal of machine learning is to design algorithms that automatically improve with experience. They build mathematical models from training data and use those models to make predictions or decisions, without us having to program every rule by hand. So you can think of machine learning as code that writes itself, based on examples, not explicit instructions. Now, without a doubt, machine learning models have become one of the defining technologies of our time. Banks use machine learning to predict loan default risk based on patterns in historical data. Machine learning models can identify patterns in X-rays or MRIs that might indicate disease. YouTube and other streaming platforms learn from patterns in your viewing habits to suggest what you might enjoy next. Factories use machine learning to anticipate equipment failures from sensor data. Uber adjusts prices based on real-time supply and demand. Machine learning is powerful, but it has limitations. It makes predictions based on past patterns, which means it can fail when conditions suddenly change. That's why machine learning models must be retrained regularly on new data. Machine learning is no longer just for tech giants. Your iPhone's neural engine can run machine learning models that once required supercomputers. We've got training data in abundance. Every app interaction, sensor reading, and transaction generates valuable data for training machine learning models. And with frameworks like CoreML and CreateML, you don't need a PhD to add machine learning models to your apps. As a result, machine learning has become a practical tool that any developer can use to solve real problems. In the next video, we'll look at another crucial concept you don't want to miss: how machines actually learn.